Hey, put a finger in the sky if you want it, nigga. Hey, put two fingers in the sky if you want it. Hey, put a finger in the sky. Hello everyone. It's your boy Breezy, and welcome back to my YouTube channel. In today's video, we're going to be dealing with Newton's laws. From NSC question paper. And without wasting any time, let's just get into the video. Question 2. A block of mass 100 kg is sliding down a rough inclined surface at a constant speed when a force F is applied parallel to the inclined plane as indicated in the diagram below. The coefficient of friction for the surfaces is 0.2. The coefficient of kinetic friction for the surfaces is 0.2. That simply means that we have the kinetic frictional force. So 2.1. Define the term normal force in weights. You see, when it comes to this kind of question, you can answer it in a way that you want, because I know that we use different textbooks. So and I can just define it as the component of a contact force that is perpendicular to the surface that an object contacts. So in a way that you put it is okay according to your textbook or whatever, it is okay. So let's just get to 2.2. Draw a labeled free body diagram for the block. Okay. 2.2. This question 2. 2.2. Draw a labeled free body diagram for the block. Okay. We all know that we have the force that is always acting, which is the force of gravity. Our force of gravity is always acting, and then we can see from the diagram that we have a force that is applied over there. Then you must check it is 4 marks. It simply means that you have to get 4 arrows from your free body diagram. So the other force that we have is the force that is normal. The force that is keeping this object to be in contact with this surface, And then the last force that we have is our force of friction, because you must remember that we were told that the coefficient of the friction for the surfaces is 0.21. It simply means that we have the kinetic frictional force. And then let's go to 2.3. 2.3 says calculate the magnitude of the applied force. Okay, we are required to find the magnitude of this force that is applied over here. And then we know that we have this formula, F net is equal to mass acceleration. And then you must bear in mind that acceleration is equal to changing v over changing t. And then if acceleration is equal to changing v over changing t, and then we were told that this block is moving at a constant speed. It means if it has started with 5 meters per second, it is going to be 5 meters per second at the end, or our v final is going to be 5 meters per second. So we know that our changing v is equal to vf minus v initial. So it is going to be 5 minus 5 over whatever our time might be. We can just we can just say change in t, and it is going to be 0 obviously. So it simply means that we have 0 over here. Then we have to add all our forces, or all the forces that we have in this case. So what are the forces that we have? We have our force, that is kinetic friction, plus our applied force, plus our force parallel, our gravitational force that is parallel, because in this case we are dealing with an inclined plane. So it is all going to be 0 because of this acceleration. So when we get to this point, we need to choose a direction. So where is this block going? This block is sliding down. You must remember that it is sliding down. So we can either choose down as positive or up as positive. So let's just choose down as positive. So we are simply going to have what? We are simply going to have what is this thing? This thing, it is mu k, and what is our force? Our force we don't know because we are looking for our force, but it is going upwards. And since it is going upwards, it simply means that we are going to have a negative sign. Then what is this thing? It is going to be positive because it is going downwards. Yeah, it is going downwards. So what is this thing when we like expand it? We're going to have mg sine theta equals to 0. So okay, what is our uk? What is our uk? Our uk is 0.29. We're going to have 0.29 into, what is our normal force in this case? Our normal force in this case, we can just say, we know that we have the gravitational force that is perpendicular over here, that is perpendicular over here. So we're going to say this force plus this force is equals to mg. Then we're going to say normal force equal to mg minus f vertical, because it is vertical obviously. So what is our normal force in this case? Normal force is going to be mg minus force that is vertical, minus our force over here, plus what is our mass? Our mass is 100. Our g is 9.8. the sine of 25, sine 25 degrees equal to 0. Then we are now going to say, let's just not multiply at this point. 0.29 into, what is our mass? Our mass is 100 into 9.8 minus, what is FV? Our force that is vertical. It is F sine theta. Yeah, it is F sine theta. Yeah, it is F sine theta. So what is it that we are going to do? We are going to say F sine, what is our angle? 25. We are here. Then minus our F, then plus, let's just get this one into our calculator. You're going to have into 100 multiplied by 9.8 multiplied by sine 25. We are going to have 4 1 4 comma 1 1 6 5 8 9 6 5 is equal to 0. Sorry about that one. It is equal to 0. Then when we get to this point, we are now going to say 0.29 into What is 100 multiplied by 100 multiplied by 9.8? 100 multiplied by 9.8 is 980 minus 980 minus sin 25. What is sin 25 minus let's just write it like this: sin 25 minus our f, then plus this number again, 414,1658965 is equal to 0. Then when we get to this point, we are now going to multiply. Then we are now going to say 0.29 multiplied by 980. It is 284,2 minus 0.29 multiplied by sin 25 is going to be a small number, that is 0.1225592959f minus f plus 414,1658965 equal to 0. Yeah, so after let me just take a new page over here. Yeah, so after writing this thing like this, you are now going to say, let me just put it like this so that you can be able to see what's going on. But this one is very much complex, but yeah, it's physical sciences anyway. So from now on, we're just going to do maths. We're just going to apply maths, so after doing this thing, you are now going to like add this one. We call them the like terms. So let's just say pre-answer, let's just not say pre-answer, 284,2 plus 414,1658965. It is going to be 698, okay. So we are now going to say, let's just we're now going to say 698,365,8965. Yeah, we are now going to have this kind of thing, so after having this thing, we're going to say minus 0.122 and this thing minus 1. It is going to be 1,122,559,2959f equal to 0. Then we are now going to transpose this one into that side so that it can be positive. Then we're going to have 698,365,8965 equal to 1,122,559,2959f equal to 0. Then after this one, we are going to say we divide this thing all over by 1,225592959. 1,225592959, and this one is going to cancel this one. Then we are going to be left with f equal to, we have this number already, we're just going to say divided by 1,22559,259. Yeah, it is equal to 569,82 newtons. Yeah, it is 569.82 newtons. Yeah, so let's just get to the last question. Which is 2.4. It says name the force that will form an action-reaction pair with the normal force in this case. Okay, one thing that you need to remember is that when we talk about an action-reaction pair, we are actually talking about, or it is the case whereby two bodies interact and they exert equal and opposite forces on each other. So you must remember that a normal force is acting that way. So what is the force that we will have that will be acting with normal force in an opposite way, and also exerting the same amount of force that normal force is exerting on this scenario? It is going to be a gravitational force perpendicular. So our answer is FG, perpendicular. And sorry for my voice, I'm actually tired now because it is around 3 a.m. So yeah, but thank you very much for watching this video up to so far, and it really means a lot. It really means that you really enjoyed this video, and please subscribe to my YouTube channel and give this video the thumbs up if you have loved watching this video, and hit that notification bell so that you can be notified whenever I post these kind of videos. Thank you very much.